Sometimes you have to admit you were wrong. While advocating for DevOps best practices, distribution, microservices, and other fancy deployments, over the past couple of years, working with startups helping them with their system architecture in the cloud, I've seen small teams using one server with a few containers running on it, making hundreds of thousands of dollars every month. No scaling rules, no fancy monitoring options, just a plain VPS and some raw processes making cash. Now, sure, they called me in because they needed some improvements, but nevertheless, a basic raw system was doing a pretty good job. Until things started breaking. After over a decade working with containers, building hyperscale production environments from scratch, and working with developers ranging from high school dropouts over to senior 10xers who saw everything, I noticed that they're all missing something about how they work with multi-container environments. Docker Compose is the go-to option for local development with multiple containers. It makes things easy by letting you preset environment variables, dependencies between running containers, it lets you isolate networks, but most importantly, it lets you start and stop an entire fleet of applications with one command. But when things need to step up and move over to production, most teams just take things as is and run them on a remote VPS in the cloud. This is missing the entire point. I'm not advocating you drop Compose altogether. Sure, it's not the best idea to run it as a long-term production solution, but nevertheless, it's more than capable and even supported officially in the docs. Okay, I think we're going a little bit too fast here. Let's step things down a notch, and in order to build a real production beast, let's take a look at the Compose basics. To show something running in Compose, I have my famous guestbook app, which, thanks to Claude, is now simplified. The code isn't very interesting other than the fact that it's currently speaking to Redis through localhost or a given environment variable. Running processes naively pops a message about Redis not being available locally, so it won't start. To this end, let's do it the old way. Run Redis on a local process, with which the app can now run smoothly. Let's even pop the web page it serves and sign the guestbook. So far so good, but that's pretty basic. Now let's make it interesting by serving Redis instead of a local process as a container. And since I have to be different, in this instance I'll be using Podman to run Valkey, which is like saying I'll be using Docker to run Redis, but a little bit more open source. There's a video above here on Podman and another one for Valkey right here and on the channel's recent releases. Okay, I'm done being a hipster. Let's run the application again by starting the process as is, and it still runs. This time speaking to Redis, or Valkey to be precise, served from a local container. But that's cheating a little bit. Since Redis isn't really running locally, it's running in a container that exposes ports, which is nice and all, working locally. Even scaling it up one more replica would create a conflict of served ports, so not ideal. Let's fix this by building a Docker file, or a container file if we keep the hipster theme. This is a rather simple container file, taking Golang as a base layer, using it to build and compile the code, which is then sent to the from scratch container that holds the binary. By the way, if you're curious about the process, please stop this video and leave a comment below so I can gauge the interest in building great, light and fast containers. Anyway, building the image with either Podman or Docker shoots the familiar no Redis available error. Good, let's give it its Redis, shall we? Podman run a detached Valkey with the ports mapped outside. Then run the app again and what? Still no Redis? What's going on here? Here's the thing. Remember our application is pointing at localhost in the Redis port? Well, running inside a container, localhost is no longer the actual host, but the container itself. So while Redis is exposing the right ports, they aren't available on the container's local path. There are creative ways to fix this, of course, but the golden standard for multi-container environments is Docker Compose. A quick break for a word from today's sponsor. Ever wondered how companies like Brave, Discord, and Intel handle global software localization? Meet Crowdin, the AI-powered localization platform that seamlessly integrates with your development workflow. Imagine your translations updating automatically with every commit. No more manual file handling or coordination nightmares. Just push your code and Crowdin's AI handles the rest, supporting over 600 integrations while maintaining your rapid deployment pace.
Join the 3 million users who trust Crowdin.
Ready to go global? Start free at crowdin.com and let your code speak every language. Now, back to the video. Now, I'm assuming basic level of familiarity with Compose, but even if you don't have it, it's rather straightforward. Compose is a YAML holding a list of services, which are containers and their optional settings like an image, ports, environment variables, and more. We have two here, Valkey, which is our Redis cache, and app is the guestbook webpage. Compose allows for a depends on entry to make sure the container doesn't fail over not finding Redis until Redis is fully ready to work. Lastly, since Compose is looking for a Docker file and I'm building a container file, I will explicitly tell it to build that, and now we can start building. Docker compose app --build tells Compose to ignore pre-built images if it has something cached and rebuild from scratch. Once built, Compose turns to running them, and while Valkey is doing fine, our app still doesn't see Redis. Let's fix this again. Remember how it looks for localhost at port 6379? Compose, using the Docker local container network, maps the running services directly so we can call them by name. By the way, this is extra cool when running more than one replica of a service, since it also serves as a lightweight load balancer. Okay, with the guestbook addressing Valkey directly, let's build and run again, and there we are. The guestbook is ready to serve.
So, Compose is working, but this video is meant to address how most Compose users are missing the point, and a closer look at the current setup tells us two things. One, it's not good for development. Rebuilding and running two containers with every line change is annoying, to say the least. On the other hand, this isn't production ready. The hard-coded ports, lack of watchdog functionality to restart containers when they crash, and other features are simply missing. So how do we make Compose perfect for both scenarios?
Let's start with devs working locally. To adjust the current file in making development a breeze, I'll change the image to the base image used to build the container. We'll also add a command to run the process directly, and most importantly, mount the current working directory to the container so that changes I'm working on will be immediately reflected inside the container without having to rebuild it. With the current directory mounted to /app on the container and a proper command to run, Compose logs now have some Go libraries installations and we're good to go. Loading the web page looks fine, but let's make sure things can be changed in real time. Let's make an HTML change to the web page, which is part of the code mounted. I'll change the placeholder, and without having to touch anything but a page refresh, we can now see the new line. This makes development a breeze, no restarts, no rebuilds. You can even add a hot reloader like air, for instance, to detect Go changes and restart the process without having to touch it at all. Right, dev workspace sorted, but how does this translate to production? There are multiple ways. Compose can actually be translated to many other tools. AWS will offer a direct translation to their orchestrator ECS. Naturally, it can be ported to Kubernetes, which is an overkill, to say the least. In this instance, you can use other orchestrators, even the one Docker themselves built, called Docker Swarm, which is the bigger brother of Compose. So, before doing all that, let's go with the one naive option I didn't mention, and so many teams starting out are actually opting for, using the same Compose file in production.
Is it great? No, but there's a way to make it slightly less error-prone. Is it terrible? Well, like I've said, seeing more than a few teams making huge bucks with Compose on a single machine, I had to take my hat off more than once and give it to them. So for the teams who are going to production with Compose, let's do it right. Let's make Compose great again.
So, Docker Compose has the hidden feature most teams I've worked with tend to miss. It can override and merge multiple files. Why is this important? Well, instead of changing Compose to work in production or holding two versions of the same file with tweaked configuration, we can create production YAML and only make changes to the relevant areas. Let's assume Valkey stays the same for the sake of simplicity, and the image we're going to run is a pre-built image the host will download. The command and working dir aren't necessary as well because they're outlined in the container's image, but let's ignore them for now. But as for the volumes, we can't have that. We don't want the code to be overridden by the host, mainly because it's not going to be there in the first place. Compose has a weird way of overriding file configs using the not reset notation and the target reset, which in this case is an empty list. Now, we'll run Compose with two file flags. The first is the dev compose and the second is production compose, making the second layered on top of the first. Before actually running it, Compose comes with a config command sending the results to a file. Looking for the volumes entry comes up with an empty pattern, so we basically got rid of those. Everything seems fine, so it's time to push to production.
changing config to simply run and compose this app with production settings. We can even sign the guestbook successfully.
Now, you may be asking yourself, what? Am I going to have to physically run these containers and watch them? What happens when a new version requires an update? You have great questions.
To start, Compose has the ---- no deps flag that allows for a replacement of any container in the stack, while ignoring its dependent services, keeping them alive. Running that in Docker Compose PS shows the guest app container was started again 14 seconds ago without interfering with Valkey. Okay, but do I need to physically run that from within the server? Isn't SSHing kind of beats the purpose? You can configure the local Docker host to point at a remote one and then run Docker Compose app detached or replace a container version, etc. Better yet, run this from a CI server with access to protect yourself better and employ automation instead of having to run manual commands. Lastly, before Swarm, Compose also comes with the restart always pair, allowing for a native watchdog restarting containers when they crash, keeping the system healthy automatically, and adding to that, making sure it's even more resilient and can overcome server restarts. I tend to add Compose to systemd, the famous Linux service manager you can find on pretty much any flavor of the operating system. A short entry of Docker Compose app and restart equals always in case of process crashes, and you're good to go.
However, when you find yourself looking for scale, rollout options, rolling updates, alerts and more orchestration features, given that you'd like to stick with Docker, or at least the current Compose setup, the next best option is Swarm. Now, this deserves one important clarification. Docker Swarm, which is now called Swarm Mode, is not to be confused with the container clustering system Swarm Classic, which was stopped being updated during COVID and is now archived. Swarm Mode, or Swarm Kit, is built into Docker, comes with lots of nice features, and you can read all about them in the documentation. And please do comment below if a deeper dive into Swarm is of interest, but for now, let's use the basics.
Using the same Compose YAML, making it more simple for the example, I can now add the entry deploy and replicas underneath it. Let's make sure the guestbook app runs 2 instances and start Swarm. To do that, we'll run docker stack, and if you want these fancy autocompletions like mine, check Carapace, also mentioned on my Nushel video above. Make sure you run docker swarm init to start the virtual Swarm host, and now docker stack deploy -c the YAML file and guest for the application's name, and there we have it. Docker stack ls now shows the guestbook app with 2 services running. Docker stack ps guest shows a bunch of containers. We have 2 guest containers and 1 Valkey as requested. For a more clean view, we can just go for docker ps. Now let's scale it up. Docker service scale guest _app equals 3 replicas, and Swarm takes care of the service, now running 4 containers, 3 for guestbook and 1 for Redis Valkey.
With Docker Compose in production, you may want to give another look at your local tooling. While the Docker engine is open source, other components such as the Docker desktop aren't free for commercial use. Check Podman, an open source alternative with rich Kubernetes features allowing for an upgraded local container experience on the next video right here. Thank you for watching, and I'll see you on the next one.